Hi, and welcome to Element Z3, Planet Earth and Beyond. Grade 7 Natural Sciences, Study Notes, Term 4. Solar Energy and the Earth's Seasons. Solar energy. The sun radiates heat and light in all directions, and the earth receives this energy as heat and light, solar energy. Earth's rotation. The earth spins on its axis once per day. The axis is an imaginary line through the center of the earth, from the North Pole to the South Pole. Tilt of the earth's axis. The earth's axis is tilted at an angle of 23.5 degree from the vertical. This tilt does not change as the earth orbits around the sun. Seasons. The tilt of the earth causes different intensities of solar energy to reach different parts of the earth throughout the year, leading to the four seasons. Summer, when the solar energy falls more directly on the southern hemisphere, it is spread over a smaller area, causing summer. Winter, when the solar energy falls at an oblique angle on the southern hemisphere, it is spread over a wider area, causing winter. Day length. In summer, days are longer than in winter due to the tilt of the Earth's axis. Solar energy and life on Earth. Photosynthesis. Plants absorb light from the sun and produce energy containing food through photosynthesis. Food chain. All plants and animals depend on this process for their energy. Fossil fuels formation. Dead plants and animals can eventually form coal, oil, or gas, fossil fuels, over millions of years through being covered by layers of mud and soil, pressure from these layers, long periods of time changing the remains into fossil fuels. Energy storage. Coal, oil, and gas store energy from the sun absorbed by plants millions of years ago. Non-renewable resource. Humans use this stored energy faster than it is being formed. Flow of energy from the sun to fossil fuels. Sun, source of solar energy. Plants absorb solar energy and convert it to food. Animals eat plants and obtain energy. Death and burial. Plants and animals die and get buried under layers of soil. Pressure and time. Over millions of years, pressure and heat transform remains into fossil fuels: coal, oil, gas. Relative positions and gravity. Moon's orbit. The moon revolves around the earth. Gravity. The tendency of objects to attract each other. The pull of gravity depends on mass and distance. More massive objects exert a stronger pull. Closer objects exert a stronger pull. Earth's orbit, held by the sun's gravity. Moon's orbit, held by the earth's gravity. Moon's gravity also has its own gravity affecting tides on Earth. Tides. Tides. The predictable repeated rise and fall of sea and ocean levels caused mainly by the moon's gravity. High and low tides. The moon's gravity pulls on Earth's oceans, causing 2 high tides and 2 low tides daily. Spring tides. When the moon aligns with the sun, full moon and new moon, higher than usual high tides and lower than usual low tides occur due to the combined gravitational pull. Shoreline ecosystems. Shoreline ecosystems. Unique ecosystems between high and low water levels sustained by tides. Ecosystem. A community of living organisms interacting with their environment. Early indigenous knowledge. Observations. People observed predictable patterns of the sun, moon, and stars to measure time and develop calendars. Year includes the four seasons, month from one full moon to the next, day from one sunrise to the next. Uses. Patterns were used for planting, finding direction, and marking holy days. Cultural stories. Knowledge passed on through stories about the sun, moon, and sky patterns. Modern developments in astronomy. Copernicus, 1514, suggested the sun is at the center of the solar system. Galileo, 1610, made the first telescope to observe planets and their moons. Kepler, 1609, used mathematics to describe orbits accurately. Newton, 1687, showed that gravity holds the solar system together.